Hey everyone! Welcome back to ZoomInData. And this is episode 27 of our KQL Concepts Deep Dive series. Today we are diving into dynamic and bag data types, how KQL handles JSON arrays, objects, nested structures, and semi-structured data natively. We are keeping everything pure concepts and interview focused. If you missed episode 26 on parsing semi-structured data, it's a perfect lead-in for today's topic. Let's get started. Here is our roadmap for today. The dynamic type is KQL's flexible container for JSON-like data, objects, arrays, primitives, nested structures. Bag is essentially the same type, synonym in most contexts. You access nested fields with dot notation, array indexing, and dynamic functions. Common operations include bag_unpack to flatten, mv expand to turn arrays into rows, toDynamic to parse strings, and toString for output. Performance note: dynamic columns are slower than strongly typed columns. Avoid overuse in large datasets. The killer use case is parsing and querying JSON logs and telemetry without rigid schema on red power. Let's go under the hood. The dynamic type is KQL's way of representing JSON natively. It can hold scalars, int, string, bool, objects, arrays, or null, full JSON fidelity. You create it with toDynamic, JSON_string, or parse_JSON, on a string column. Access nested values with dot notation for objects, dynamic object, property, subproperty, or bracket indexing for arrays, dynamic array, 3. Missing paths return null, safe and graceful, no errors. This is pure schema on read. No need to predefine columns, ideal for evolving JSON payloads where fields come and go. Dynamic gives you the flexibility of JSON without forcing rigid tables. Two powerhouse operators for dynamic data: bag_unpack and mv expand. Bag_unpack, dynamic, flattens a top-level object into separate columns, turns A, 1, B, X, into columns A and B. mv expand takes an array column and explodes each element into its own row, perfect for turning lists into tabular data. When combined with dynamic, mv expand can explode nested arrays or objects row by row. Common pattern: parse_JSON to get dynamic right-pointing arrow, mv expand on array fields right-pointing arrow, bag_unpack remaining objects. Big warning: mv expand increases row count dramatically. Always filter aggressively before exploding to avoid memory blowup. These two functions turn nested JSON chaos into clean, queryable tables. Check out this side by side. It shows the two main ways to tame dynamic JSON data in KQL. On the left, a JSON string goes into parse_JSON, becomes a dynamic object with properties. Then bag_unpack flattens it. Top-level keys turn into clean, flat columns. Simple, fast, no row explosion. Perfect for object payloads. On the right, a dynamic array, item 1, item 2, hits mv expand. Each element becomes its own row. Great for turning lists, tags, events, nested arrays, into queryable tabular data. The middle arrow says flatten and explode. Bag_unpack flattens objects sideways into columns. mv expand explodes arrays downward into more rows. But watch the warning icon. mv expand can massively increase row count. Filter aggressively first or you risk memory blowup and slow queries. Use this combo wisely. Parse_JSON right pointing arrow MV expand arrays right pointing arrow bag_unpack objects right pointing arrow work on flat columns. That's the golden pipeline for turning nested JSON chaos into fast, scalable analytics. KQL gives you rich dynamic functions for manipulation. Array_length, array_index_of, array_slice handle arrays. Dynamic_to_JSON converts back to string formats for output. Set_or_append builds dynamic objects or arrays incrementally. Dynamic checks membership in dynamic arrays efficiently. Performance tip. Extract simple scalar fields early with extract or parse. Only use dynamic for truly nested, complex parts. Avoid carrying large dynamic columns through heavy operations. They are slower than typed columns. Best practice. Parse right pointing arrow, extract right pointing arrow, dynamic only when needed, right pointing arrow, flatten with bag_unpack, MV expand. Keep dynamic usage surgical, powerful but not free. Trade-offs and pitfalls. Dynamic gives ultimate flexibility. No schema breakage on evolving JSON, but typed columns are faster and more memory efficient. Pitfall 1. Keeping large dynamic columns through heavy operations leads to slow queries and high memory usage. Pitfall 2. Deep nesting creates long dot chains with lots of null checks. Best practice. Flatten early. Parse_JSON to get the dynamic object, MV expand arrays into rows, bag_unpack objects into columns, then work with flat columns afterward. Pipeline pattern. Parse the JSON. Extract simple fields. Use dynamic only for complex nesting. Flatten as soon as possible. Dynamic is a superpower for semi-structured data, but treat it as a temporary bridge, not a permanent home. Flatten fast. Query fast. Why does this topic matter in interviews? JSON and log handling is core KQL skill. Interviewers test it heavily. Common questions include, how do you flatten JSON arrays? Bag_unpack versus MV expand. Dynamic performance tips. Understanding dynamic versus typed columns shows scale-aware thinking. It's critical for telemetry, log analytics, and semi-structured data roles. Explaining the flatten early pattern, parse, explode, unpack query flat, demonstrates production expertise. Nail this, and you prove you can tame messy JSON at scale without performance surprises. To wrap up, dynamic and bag types give KQL native JSON support, objects, arrays, full nesting, access with dot notation, array indexing, and dynamic functions. Flatten with bag_unpack for objects and MV expand for arrays. Performance key. Dynamic columns are slower. Flatten early to typed columns whenever possible. The winning pipeline. Parse_JSON right pointing arrow MV expand arrays right pointing arrow bag_unpack objects right pointing arrow query on flat columns. This approach turns complex semi-structured data into fast, scalable analytics, core to modern log and telemetry workloads in KQL. That's episode 27 done. Thanks for spending time with me on ZoomInData. Next in episode 28, Materialized Views, we will explore incremental aggregation, query rewrite, and how they supercharge performance. Homework to lock this in. Explain to someone or out loud. What is the difference between bag_unpack and MV expand? Think of a JSON log pattern and how you would flatten it step by step. Answer this one. Why flatten dynamic data to columns early? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 28, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.